Good evening and welcome to Unit 6 of our Methods of Teaching SHS Mathematics. And the Unit 6 deals with teaching selected SHS topics. The first session, or in the first case, we are going to take the Pythagorean theory. So we are teaching the Pythagorean theory is our session 1. At the end of this session, our objective is that at the end of this session, you will be able to guide learners to derive the Pythagorean theory and use the theory to solve related problems. The Pythagorean theory states that the number of unit square found in the square built on the hypotenuse, that's the longer side, of a right angle triangle is the same as the sum of the number of unit squares found in the squares built on the two shorter sides of the triangle. So to show this, we raise squares on the sides of the right angle triangle ABC and divide them into unit squares. So you guide your student to identify the hypotenuse as the longer side and the side which faces the right angle, that's the 90 degrees. So ask your student to do the following practical activities. So this is one of our practical activities. Draw a right angle triangle with one side 3 squares long and the other side 4 squares long. Then investigate the area of the bigger square. Now this figure, we determine the number of squares units on the longer side, that is 25, and those on the shorter sides to be 16 and 9 as shown in the diagram. We notice that the sum of squares units on the two shorter sides, when we add them up, we are going to get 16 plus 9, which will give us 25. So the longer side is going to have 25 of the square units. So the area of the bigger square is 25, and this implies that we can write this one mathematically as 5 square to be equal to 3 square plus 4 square. This is repeated for right angle triangle with sides of various measures, say 6, 8, and 10 centimeters each. In each case, we notice that the sum of unit square on the two shorter sides is equal to the unit squares on the longer side of the right angle triangle. The Pythagorean theory in algebraic form. So we want to write this one in algebraic form. In the algebraic form, the theory states as follows. If for a right angle triangle with A and B as the measures of the two shorter sides, and C is the measure of the hypotenuse, that's the longer side, then A squared plus B squared is equal to C squared. We can prove this theory intuitively as follows. We consider a right angle triangle with the two shorter sides of measure A and B and the hypotenuse of measure C. Yes, so you can guide your student to observe that we have two figures here, figure I and figure II. The same size square has been partitioned in two ways. So these are the two ways that we have been partitioning them. Now in figure I, we found a square. This is the square in the figure I. And 4 triangles all of the same size. 1, 2, 3, 4. So these are 4 triangles. So you can let your students observe also that in figure II, that's this figure II, we found 2 smaller squares and again 4 triangles all of the same size. So 2 smaller squares can be found here and again 4 triangles all of the same size. Therefore the squares in figure I must have the same area as the sum of squares in figure II. We can write this relationship as A squared plus B squared equal to C squared, where C squared is the area of the squares in figure I, and A squared plus B squared is the sum of the areas of the two smaller squares in figure II. Guide your student to notice that the converse of the Pythagorean theorem is also true and is of great use. The converse of the Pythagorean theory states that if the measure A, B, and C of the sides of the triangle are such that A square plus B square plus C square, A square plus B square is equal to C square, then the triangle is a right angle triangle with A and B being the measure of the shorter sides and C the measure of the hypotenuse. Thus, a triangle whose sides measure 3 centimeters, 4 centimeters, and 5 centimeters is a right angle triangle since A square plus B square, since 3 square plus 4 square is equal to 5 square. You can find out whether triangles whose sides are multiples of measures of the 3, 4, 5 triangles, 3, 4, and 5 triangle are also right angle triangle. For example, if the measure of the sides of triangles are 6, 8, and 10, then it is a right angle triangle since 6 square plus 8 square is equal to 10 square. So whereas that the 6, 8, and 10 are multiples of 3, 4, and 5 with a common multiplier. We notice that any positive integral multiples of 3, 4, 5 triangles is a right angle triangle. This ends the session, and this session we try to derive the Pythagorean theory and use this theory to solve related problems.